Hey guys, welcome back to Intellipaat. So in today's session, we will understand what is Hadoop. But before we understand that, let's actually address another question. Where does Hadoop really sit in an enterprise? So we'll first answer this question with an example, and then we will explore Hadoop. So let's start with a very small story and we should be good to go. So I am Jeff Bezos, CEO of this e-commerce site called as Amazon. And you guys are my technical guys. So as of today, our organization looks something like this. We have our e-commerce site and that runs out of Oracle. We have our inventory and that runs out of MySQL. So life is very easy over here. Everything is awesome. So now if I wanted to answer a question, let's say how many iPhones should be ordered next month? Very simple stuff, right? Now to do that, typical way of doing things would be to load all of this data to a data warehouse. Let's say Teradata. And then you basically do your reporting. So that's where you have tools like Tableau and ClickView. So all of your data gets generated, you load it into a warehouse, and life is very simple. But there's just one problem. So the real problem in this whole setup is that this would have worked very well till let's say 2000 or 2005. Today, we are in 2018 now, and the questions are not that simple because the amount of data that we're looking at is very, very huge. So let's take a simple example. Now, if I was to change the question and say, how many customers bought the iPhone, loved it, but hated the delivery, but instead of talking to us, they vented anger on Twitter. Now, first thing is that the data, which is coming from sources like Twitter and other sources like your sensors, network logs, and cloud. So this data being generated is really, really huge. And it's not going to fit into your traditional database systems. Okay. So Michael has a question here. He asks, are you talking about big data? Yes, Michael, you are absolutely right. So all of this huge amount of data coming from different sources and present in different formats is nothing but your big data. And we require something new to store and process this big data. So that's where we decide to bring in another system. And the system is called as Hadoop. So now think of Hadoop in a very crude way as a very big data warehouse. So it can take data from anywhere and it can easily host a single master and theoretically tens of thousands of nodes. It also gives you two services, storage and process. So this guy can get data from traditional databases and other sources as well. Now this guy lets you store data and process the data. So think of Hadoop as somebody who complements your warehouse, typically to store a lot of data and then process it. Now, after you store and process the data, whatever final processing is done, you can load that final thing into a warehouse. And that is what is called as analytics. And you're free to directly connect to a reporting tool also. That is also possible, guys. So based on your pattern, you can choose what you really want to do. So that's the idea behind Hadoop. So you put all of your data at one place and process it. And whatever comes out, you can load into a warehouse or you can directly connect it to a reporting tool. And there's another instance. Now, if you load this back to Oracle, man, it becomes recommendation engine. So think of it this way. From all the sources that we've got our data, we learned that 85% of people buying iPhone also bought a screen guard. And 81% people buying an iPhone also bought a back cover. Now, once we learn this within Hadoop, we can load this back to Oracle. And when the next customer comes to our e-commerce site, we can always show them that people who bought an iPhone also bought screen guard and back cover. So think of Hadoop as a very big data store. It can store the data, process the data, and then you can use it the way you like. So guys, I hope everyone is clear on what Hadoop is. So just give me a quick confirmation so that I can move ahead. Okay, so Ram confirms that he's clear. So does Anne. Okay, so seems like everyone's good. So guys, now we'll understand the storage and processing part of Hadoop. But instead of just going through the names of the processes, I want to take a small story because that way we'll have the entire understanding. So this is Kailash, CEO of Tama Consultancy Services. And the company's presence is in over 150 countries. And people all over the world love the company. So just yesterday, the company's Facebook page got 1 billion likes. So now the CEO wants to create a huge dashboard where they get to see the whole globe and on hover of each country, it displays how many likes they got from that country. So now this task is assigned to Ajay, who is the project manager, and he's supposed to get the dashboard made in 4 days. Now, let's say Ajay wants to use Hadoop for this, and he has 2 members in his team, Mr. Admin and Mr. Developer. Now, Ajay tells Mr. Admin, dude, go set up the Hadoop cluster. And he tells Mr. Developer, listen, you're supposed to develop the whole dashboard. So let's see what happens right now. So first admin comes in, he purchases 5 machines and decides that 1 will be master and 4 will be slaves. So Mr. Administrator has come to work and he's setting up a 5 node cluster with 1 master and 4 node slaves. And Hadoop is all about storage and processing. So on the master, he installs somebody called as storage master. And on the master again, he installs processing master. Now on the slaves, he installs storage slave and processing slave. So he does this for all of the slaves. Now admin tells Ajay, boss, setup is done. Go ahead and ingest data and write the program. So now Ajay calls Mr. Developer and says, Mr. Developer, go ahead and please load the data and write the code. So the developer takes the data, which is, let's say, facebook.json, and the file size is around 640 MB. So when he writes to storage master, the file is actually broken down into blocks of 128 MB. So 640 divided by 128 means 5 blocks, and each block is replicated 3 times. So that makes it 15 blocks. Okay, so there's a question from Deepak. He asks, why is the block replicated 3 times? Good question, Deepak. So we actually have the concept of fault tolerance in Hadoop. Now, even if the original block gets corrupted, you have 2 more copies of that block to retrieve the data. And this is what makes Hadoop so reliable. So does that answer your question, Deepak? Alright, so Deepak's good. So now these 15 blocks of the original file are distributed across different slave nodes. So let's say 4 of these blocks are stored on the first slave, 4 on the second slave, 4 on the third slave too, and 3 on the final one. So now the data is ready. It is already broken down into blocks, but when it comes to storage master, it will only have the metadata. So the metadata looks something like this. Now facebook.json is nothing but block 1, 2, 3, 4 and 5. And block 1 is present on slave 1, 2 and 3. Block 2 is present on slave 2, 3 and 4 and so on. And this is what is stored in the metadata. So there is no problem of memory in storage master because master is storing only the metadata and not the entire data. Now because of that, memory is not at all an issue. So irrespective of how big a file you write, it uses memory of name node only for metadata. But the original data is actually written to the slaves. Now let me just give you guys a simple example for this. So let's just say there's a project manager who has 4 people in his team. Now project manager just knows what tasks people are doing, but all the tasks are actually done by the slaves. So that's why manager is not the bottleneck over here, and neither is his capacity to know which data is stored where and which task is running where. So manager is doing nothing in this. He only has the metadata. Okay, so now your data is stored, developer has taken the data and he has written it to the storage layer, and all the data is spread across and it's done. So now the developer goes ahead and also writes the program. And because the task is to find the number of likes by country, let's say the program name is group by Java program. Now this Java program gets submitted. So the processing master copies this code on every machine. Now master will basically say that, okay, listen up Mr. 4 slaves. Slave 1, you process block 1 and block 2, which is local to you. Slave 2, you process block 3, which is local to you. Slave 3, you process block 4, which is local to you. And slave 4, you process block 5, which is local to you. So do your business locally, don't talk to the network, and the job has to be done. And then you get your final output, which can then be directly shown on any reporting tool, or you can load it to a warehouse and perform analytics on top of it. So this is how Hadoop really works, guys. So this is Hadoop for you. So now let's quickly get into the process names. So far we've learned that Hadoop gives you 2 services, storage and processing. So the team that gives you storage is called as HDFS, and the team which lets you do processing is MapReduce. Now again, since this is master slave, so the master in HDFS is called as name node, and the slave is called as data node. In MapReduce, the master is called as job tracker and the slave is called as task tracker. So for storage, it is name node and master node, and when it comes to processing, it is job tracker and task tracker. Simple stuff, isn't it? So life is very, very easy over here. Now, this particular setup had one very serious limitation. You could only write programs in MapReduce. So whether you like it or don't like it, you could write programs only in MapReduce or any other framework that runs on MapReduce, but you can't have anything else. So let's take a simple example. Let's say I'm a layman, like a proper layman, guys. Now there is a problem in my iPhone battery. So can I just buy a new battery and put it in my iPhone? So can a normal person walk into a store and buy a battery for the iPhone? Obviously not, right? And this is because Apple tells you that if you want to use my phone, you'll have to use only my battery. You like it or you don't like it. You can't just buy any battery and plug it into the phone. Very similarly, if you wanted to use Hadoop, Hadoop would say, hey buddy, use it. But you have to express yourself in MapReduce only. So it's a very serious limitation. And that is why it was called as Hadoop 1.x. But what you really wanted was something better. So that's why we had another version of Hadoop where we had storage, but instead of MapReduce, there was a new component called as Yarn, which is nothing but resource manager and node manager. Now what Yarn would do is it says, I'll give resources to anybody, be it MapReduce, Splunk or Storm, it doesn't really matter. So in Hadoop 1.x, MapReduce was the only way. In Hadoop 2.x, MapReduce is one of the ways. I'm reiterating it, guys, so just please concentrate on this. So in Hadoop 1.x, MapReduce is the only way. In Hadoop 2.x, MapReduce is one of the ways. So now this course is all about 2.x and we're not going to discuss 1.x at all. And the reason that I explain 1.x is because, let's say, can I explain good health without explaining bad health? Probably is going to be tough. So very similarly, if I had to explain 2.x, I should first show you 1.x and the serious limitations over there, and that's when I bring in 2.x. So 2.x is basically a generic resource manager which says, everybody who needs resources, come, I'll give you the resources so that you can do the job. So that is how 2.x really works. So now let's look at the processing part in Hadoop 2.x. Now here we'll have Yarn master, which is called resource manager. We also have the Yarn slave. So my storage layer remains pretty much the same. I write my data and it is processed. But when I submit my job to Yarn master, Yarn says, hey man, I don't know how to run MapReduce, but I know a guy who is called as app master. He can do MapReduce for me. So I'm the resource manager. I only give resources to people. I don't know how to do processing, but I know another guy called as app master and he'll do that job. So now Yarn will initialize an app master on any one slave. Now this app master is basically a process that'll do the job. So who's responsible for the job? It's app master, guys. So Yarn master says, hey app master, I have a new job for you. Why don't you do it? So now app master will go to Yarn master and say, boss, if you want me to do the job for you, please give me the following things. So give me 2 resources on slave 1, 1 resource on slave 2, 1 resource on slave 3, and 1 resource on slave 4. Why? Because data locality is important. So Yarn master says, okay, go ahead, take the resources. And the app master can go ahead and fire the job everywhere. So the idea here is, Yarn master does not do the job. It only gives the resources. So this is Yarn for you. There is one more thing as far as this whole detailing is concerned. In 1.x, MapReduce is the only way. In 2.x, MapReduce is one of the way. So why do we need to go for 2.x? Because you need more options in life. As simple as that, guys. So I'll give you a very simple example. So there's this company called Foodpanda. So Foodpanda is a company that does food delivery for you. Now if you call Pizza Hut,
you can only get pizzas. But if you call Food Panda, then you can order from any restaurant that you really like. So think of Yarn as Food Panda, which says, listen, I don't make food, but I can always provide food services to people so that they can order whatever they want. So with this explanation, our entire landscape of Hadoop from the architectural working perspective is done. So thanks for attending this session, guys. Let's meet in the next class.
Thank you for watching the video. Do like and share it. If you have any questions, comment below and we'll respond to them as soon as possible. Also, do subscribe to Intellipaat channel so that you can keep yourself updated on the latest technologies. You can also go through other related videos in our playlist. And for more information, visit our website. Keep learning, keep improving.